right, graphing quadratics. Now, there are several different ways that we can graph a quadratic, and the one we're going to look at today is called vertex form. And this is what vertex form looks like right here. And it's this very special equation because the vertex of our quadratic is hk, which we pulled right from the equation. So if a quadratic is written in vertex form, we can look at it and find the vertex immediately just by pulling this out. But I want to point out a couple things to notice here, that this is a plus and this is a minus. So that's very important to remember when you start looking at pulling those numbers out, that this is plus k and this is minus k. And when we look at an example, you'll see. Now, the axis of symmetry, remember the axis of symmetry is that line that goes, right through the middle of the vertex of a parabola, where one side is reflected over the axis of symmetry, so it looks the same on both sides. That equation looks like this, x equals. Because it is a vertical line, it's always going to be x equals something, and it's always the x value of the vertex. So it is x equals h. So let's look at a couple of these first and just pull out of this the vertex and the axis of symmetry. Okay, so the first one here, here's my h and my k, and so my vertex is going to be 1, -4. Now notice that I got the -4 here, but I didn't pull that -4 out of there. That's because, remember, the basic form is y equals a times x minus h squared plus k. So that negative sign is right there, which means it's not part of my h. But this is a plus sign, and I don't have a plus sign there. So in order to write that in a form so that it has a plus sign, I would have to write plus -4, which is why my k is the -4. Okay, so get that off of there. So my vertex is 1, -4, and my axis of symmetry then is x equals 1. Okay, the next one, the vertex is going to be 1, 3, and the axis of symmetry is also x equals 1. The next one is -4, 1, and the axis of symmetry is -4. Now, this one I did make a negative, but that says positive because, again, remember the formula says x minus h. So in order for that to fit my form, I would have to write x minus -4. And since two negatives make a positive, we simplify it to that, but then we know that that's really a -4 for my h value. So it's -4, 1. And then this one down here, this is being added to the end, so it's my k, it's my 4. But what's being added to this x for my h? Well, nothing. So it's 0. So I could write it like this, x plus 0 squared plus 4. That's what it really looks like. But of course, we don't put zeros in there, so we just leave it off. But I know that it's 0. And then my axis of symmetry then is x equals 0. All right, so let's try to graph some. Now, I know that on your paper you have this one first, but we're going to do it second. So I want to skip to the next slide, and I want to look at this equation. So the first thing I want to do is pull off of here my vertex. My vertex is 0, 4. Okay, my axis of symmetry is going to be x equals 0. Now my y-intercept, my maximum, min, domain, and range, we'll get to that after we graph. So these first two things you can do before you graph because we're going to use them to do our graph. So let's come back up here. My vertex is 0, 4, so I'm going to put a dot at 0, 4. Right there. And now we begin the process of figuring out some other points. I could make a chart and put some values in and find the y and graph the points, but that's a really complicated and I'd rather not do it that way. So just like a line, a parabola has a certain pattern to it. If I had just the y equals x squared, I would go I would start here in my middle, and I would go over 1, so that means I put 1 in for x. Well, if I put 1 in for x, I get 1 for y, so I would go to 1, 1. Now, if I put 2 in for x, I would get 4 for y. So if I went over 2, I would go up 4. Then if I put 3 in, I would get 9. So let's say I go over to the 3, and I'm going to go up to, whoops, up to the 9. And these points right here are what make my parabola. You can see how it goes like that. Now, this is important because this pattern is what we're going to use to help us graph all of our parabolas. But you can also look at it like a slope. Now, when we counted slope of a line, we would go over and up, and then from that point we go over and up, and then we go over and up. You know, we made this kind of stair-step thing, right? So if I were to do that with the parabola, it looks very similar, but I would go over 1 and up 1, and then from there I would go over 1 and up 3, and then from there I would go over 1 and up 5. So I have 1, 3, 5. Okay, so it's either 1, 3, 5 if you're going from point to point. If you want to come back to that vertex and always go over from there, it's 1, 4, 9. Totally up to you. I'm going to use the 1, 3, 5 because I think that kind of sticks with the slope of a line that we talked about. So, and I'm going to erase all this now, so you're going to have to remember. Back to this. My leading coefficient, which is the coefficient of x right here, is just 1. So I'm going to use my 1, 3, 5 to find my next points. So I'm going to go over 1 and up 3, or over 1 and up 1, sorry. Put a point. Then I'm going to go over 1 more and up 3. 1, 2, 3, and put a point. And then I'm going to go over 1 and up 5. 1, 2, 3, 4, 5. And that one's a little bit off the graph, but that's all right. As long as you have 3 of them that are on the graph, you're pretty safe. And there's one side of my parabola. Now remember, my line of symmetry is right here, right down that the y-axis. So I'm just going to reflect my line. So there's a point here, and there's a point here, and then there's a point up there. And there's my parabola, and I'm done. So remembering our 1, 3, 5, that helps us get those points to graph, and then we just reflect. All right, so let's go back to this one, and here's why I wanted to do this one next, second, because it has a leading coefficient of -2. So we'll get to that in a second. My slope, or I'm sorry, my x-intercept is going to be 1, 3. Not my x-intercept, sorry, I'm talking about lines. Vertex, 1, 3. Okay, got that right here and right here. Okay, axis of symmetry is going to be x equals 1. So I'm going to come up here and I'm going to graph my vertex of 1, 3, right there. Whoops. Okay, now my 1, 3, 5. 1, 3, 5. My leading coefficient down here is -2. Which means I'm not going to do 1, 3, 5. I actually have to multiply this all 3 of these, by that -2 because it changes it. So what I actually end up with is -2, -6, and -10. So starting from my point, I'm still going to go over 1, but this time I'm going to go down 2 and put a dot. Then I'm going to go over 1 more, and I'm going to go down -6. 1, 2, 3, 4, 5, 6, and put a dot. The next one is over 1 and down -10. So over 1 and down, and that's going to be way off my graph. So I'm not even going to count that one. I'm good with these two. So there's my parabola, and then I'm going to reflect. Here's my axis of symmetry. So this point reflects over there, and this one is right there. And there is my parabola. And there's my graph. Okay? The only little piece that I missed was that domain and range. So let's talk about domain and range. So, on the maximum. So this one has a maximum because it's upside down, right? Nothing gets higher than that. Now that's important because that means that my y value or my x values anywhere along this line, there's a point that touches the parabola somewhere, right? I know this goes off, but it does go down there. So my domain is all real numbers. Anything will work. Now my x, however, my range, my y, is a little different because there isn't something for the y value everywhere. The y value stops at my maximum, which is 3. So my range is y is less than or equal to 3. Because anywhere down here, I've got a y value for the parabola, and then keep going. But there's nothing up here for that parabola. It doesn't exist. So my range is y is less than 3. Now your range is always going to be either y is greater than or less than wherever the vertex is. So on this one back here, I still have a domain of y's all real numbers. My range, though, this time, since this is a minimum, my y's are all going to be bigger than 4. So I'm going to do y is greater than or equal to 4, and it has a minimum. Now the only last piece we're missing is this x-intercept, and this one has none because it turns up the other direction. So I can just write none. And this one, it has some, but I've kind of erased them and made a mess here. So let's look a little closer at where those intercepts end up being. Okay, I'm going to have to draw my line again. I went over 1 and down 2, over 1 and down 6. 1, 2, 3, 4, 5, 6. And this is not going to cross nice, but it looks like about, I don't know, 2.25. You know, and then I would expect the other one to be, oops, I drew that at will. I drew that too wide, didn't I? Get my points in here. Over 1 down 2, over 1 down 6. 1, 2, 3, 4, 5, 6. There we go. And that looks like about 2.5. So I'm going to guess here that my intercepts are at negative 0.25 and positive 2.25. Yep. And if you'll remember back when we did intercepts by graphs, this is not the best way to find an intercept, but it'll work for here. All right, and that is how you graph by using the vertex form.